I love you. I'm here to make some mathematical hearts. Look at these formulas. If you plot these formulas, you get a heart. I mean, what could be better than that? This one here might be my favorite, although this one here is kind of interesting. Look at this. So we could try any of these, but I actually want to try something a little bit different here. I mean, I'm looking at this and I know what formula are there, so what I'm about to do is in no way magic whatsoever, but I want to try to get a little bit of an intuition for why that crazy formula makes a heart shape and how you might basically design your own parametric equations to generate different patterns. So there are a variety of different techniques for this. Oh, look, rotated cardioid. Oh, I love the cardioid. I have a whole video about the cardioid. And we could just graph the cardioid just with like 1 minus sine of theta. So many ways we could make the cardioid. But let's go to processing. My happy place, my love, my true love, processing. Can I put like emojis in the comments? No! I cannot put emojis in the comments. It's so sad. What did we do before there were emojis? Like this, right? Okay. Now that we've gotten that out of the way, that was very important. I'm going to go back to the curve thing. So first thing that I want to do is, this is going to be a lot easier if I think of everything as oriented around the center of the window. So I'm going to translate the origins in the top left. I'm going to translate to the center. By the way, this channel, I shouldn't call it the coding train. I should just call it, here's another example of things you can do with polar coordinates. Basically, like every video I make, it's the same. But maybe that's the theme for this week. So now what I want to do is I want to loop around all of the points of a circle. You'll see why in a second. I want to say for float A, which stands for angle. I'm going to start at 0. I'm going to go all the way up to 2 pi, and I'm going to go by some increment. I'm going to pick that arbitrarily, although there might be reasons why I want to pick different increments at some point. So I'm going to have every angle from 0 to 2 pi, and I'm also going to make up a variable called r, which is kind of like radius. Let's just set it to 100 right now. And I'm going to say, once again, here we go, sing it with me. It's the polar to Cartesian coordinate song. Auto-tune and the internet will fix that for me. R times cosine of the angle, y equals r times sine of the angle. What I want to do here is I'm going to say no fill and stroke 255 and begin shape, because what I want to do is create my own custom shape based on all of these points oriented around this circular path. Hopefully this will all start to make more sense to you. So then I can call vertex xy, and then I can say end shape, and I can run this, and you have this, a circle. Ta-da! I have made a circle. The circle, and by the way, if I were to change this increment value to something much higher, you can sort of, well, let's make it like much more extreme. You can see here, like, I'm actually just moving around the edges of a circle, and if I thought more carefully about like 2 pi divided by 6, then I might have a hexagon, all sorts of possibilities like that, right? 2 pi divided by 6. There we go. Nice little hexagon there. But this is not what I'm doing. I am just tracing the contours of the circle. Now, here's the thing. I can start to futz with these equations. For example, what if I wanted it to pinch a little bit? So interestingly enough, what if I say like cosine of A times cosine of A? Let's see what that does. Oh, weird. So you can see what that's doing. I'm squaring the value. So it's kind of squishing it a little bit along the x-axis. But of course, everything's on the right side, because if I square a negative, I get a positive. But I could go to the third power. So why don't I say power of cosine of the angle to the third power? Look at this. So you can see, like, even just doing that gets me this diamond-like quality. So that's really working for the bottom of the heart. In a way, that's the bottom of the heart, but I need to change the top. So I need to think about what I'm doing with the y. So again, I'm just kind of, this is very, in many ways, like similar to my Fourier transform epicycles videos. There's like conceptually tied here in that I'm messing with the oscillating values as I move around this kind of circular path. Now, let's do something else. Like, let's say, well, what if I take sine and I for the y value, what if I kind of multiply itself by sine of the angle, but have like the frequency doubled. So if I do this, right? Well, that's interesting. Look what kind of shape I get there. What if I multiply it by like a much more extreme amount, like 5? Whoa, look at that. So things are starting to happen. And probably actually what would be much smarter for me to try to visually demonstrate this, I have to think about this, would be to animate the process of this and actually show the separate x's and y's moving, similar to the Fourier transform videos. All right, I think it's time for me probably just to put the formula in. It's sort of interesting to explore the different possibilities here. But ultimately, if I'm seeing this equation, what I want is why these interesting numbers, right? Well, I'll get to that in a second, but let's do cosine of t. Oh, minus. I don't want to multiply this stuff together. Losing my mind here. So I want to subtract out. Yes. So as I'm getting to the top, okay, so this makes sense. So let's actually put this stuff in. Let's change this to cosine. Let's change this to sine, right? No, let's change this to sine, sorry. Let's change this to cosine. I guess I already had done that. And then I'm going to say cosine. And this is like I've got a 2, a 3, and a 4. 2 minus a 3 minus a 4. So you can see what's going on here, but you can see that it's now actually a little bit more squished at the bottom than at the top. And so what might be interesting here is to think of this as, well, if this is r, then maybe I want r times 2 times this. Whoa, look at that. Because now when it comes up, but you can start to see the heart, but it's upside down. So I kind of want -1 times the whole thing because of the way the processing coordinate system is. And we can see, look, I'm kind of getting a heart there, but I've gone to extreme. So I should probably get rid of this r thing. Let's just make r 1 and use the actual numbers. So the actual numbers in the formula are 13, 5, 2. So I can say 13, 5, 5 times, 13, 5, 2, and then cosine of 4a is not multiplied by any factor. So now if I do this, got too many parentheses here. This, there we go. Hey, look, there's the heart. Oh, I love you, heart. And then now I could scale it up by a factor. I mean, I could just use the scale function, but I could have, basically scale it up by 10. And then I could say -r times that. And there we go. So now we have made the heart. Let's animate it. This was very silly, my whole trying to walk into this formula. Really, I just want to look it up. But let's animate it. Let's have it trace the path of a heart, because that'll be really nice. So what I'm going to do now is I'm going to create an array list of p vector objects. So if I were doing this in JavaScript, this would be a much simpler, just plain array. And then what I'm going to do is I am going to not have this loop anymore, but rather have a global variable called a. And I am going to do the same exact thing, but I am going to say here, the for loop, the for loop will be for every p vector v in the heart, draw a vertex at v.x, v.y, and then what I'm going to do is each time through draw, I am going to make a new vector. I'm going to say heart.add new p vector at some x and y, and then I'm going to increase the angle by a little bit. So here we go. Bing! Yay! Okay, so I made a heart with math. I mean, this makes me so happy. My artistic talent is non-existent, but let's at least make the stroke weight a little thicker. Let's add a fill. Someone give me a nice red color, but I feel like it should be like a little darker and a little pinkish. So let's try that. And let's make sure I add close here so it closes the shape. Whoa! Oh, look at that. Oh, no, 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 no. I do not want close. I specifically do not want close. Yes, that's what I want. And now we are making this heart. Yay, I made a heart. I love it. So I challenge you to go and look at these other formulas and try them. Simon Tiger has shared with me a ton of other formulas. Maybe I'll see if any of those I want to try. But you find a formula and make your own heart. Could you do it in 3D? I bet you could make a 3D heart, all sorts of stuff. And share that with me. Coding hearts, hashtag coding hearts, coding love. For this wonderful, any day of the year. We should be making hearts all day of the year. No reason to just do it in February when it's cold outside and there's like snow and sleet and everything. Anyway, I love you. Thanks for watching The Coding Train, and I'll see you soon.